I'm only going to be able to get through some of it, so not all of it, but I'll get through the important part. I need new markers already. Rational expressions. What's rational mean? What's the definition of rational numbers? They are.
Oh.
No.
Oh, sorry.
Only the Greeks thought that.
Only positive, negatives.
Nah.
Just positive.
Oh, a quick definition. What does it mean to be a rational number?
Not
And a fraction.
It's a fraction. Thank you. So when you see the word rational, and I put next to it expressions, you're going to be dealing with fractions that have variables in them. Fractions that have variables in them. That's all right. I'm going to teach you how to deal with fractions. Rule number 1 with fractions, multiplying them. Now, I'm going to add in some other stuff while we do this. Multiply. When you're no, let's not start with multiply. Cross that out. We'll come back to it. Simplify. When we're dealing with fractions, and you leave things like this on the test, I get very upset. Because the fraction is not reduced. It's not simplified. What number goes into both of them? 5 goes into both, and you get 3 over 4. It's 3/4. Woohoo! The problem with doing it that method with numbers is fine, but with letters it becomes actually kind of confusing. So the technique you want to use with with algebraic expressions is you want to break everything into factors. So what numbers multiply together to give you 15? 3 and 5. What numbers multiply together to give you 20?
4 and 5.
Well, technically 2 times 2 times 5. I want to break it up as much as I can. Prime factors. Small little baby pieces. But yeah, 4 and 5 would work too. Now, what happens when you write it this way? Well, I can cancel, which is, inverse identity, all that fun stuff. 5 divided by 5 is 1. And what you're left with on the top is a 3, and the bottom a 4. So this method works. I wouldn't use it with numbers unless the numbers got really big. But this technique is how we're going to simplify algebraic expressions all the time. Factor, reduce. Factor, reduce. For instance, what if we had this? And by the way, for all of P6, the golden rule is factor what you see. Before you do anything, you just factor what you see. For example, 2x squared plus 5x minus 3 all over 2x squared minus 7x plus 3. Question number 1. Can I cancel the 2's?
Yes.
No,
No,
you do
you
for
gotta
the
change
you got
Can I cancel the 3's?
Yes. Yeah, because the opposite
Really?
side.
I thought we
So,
do to the
5 plus 2 over 4 plus 2 is 5/4. Is that what you're telling me?
Nah, you can't take none out. That's like multiplication.
I need everything to be multiplication. The only way I canceled the 5's over here is because it was 3 times 5 and 2 times 2 times 5. Everything was multiplication. That allows me to do division. When you have plus signs in here, you got to be very careful. Remember this long fraction bar? What does it represent? No. Other than the operation, what does it represent in mathematics? Taught you this the first day. You have long bars. They represent grouping symbols. And grouping symbols means there are parentheses. And the order of the land is parentheses happen first before anybody else. I can't do division before parentheses. What?
with that could you do like 2x?
Can I factor it?
No, like
Oh.
do what you never mind.
What I'm saying is you can't do a darn thing with this with the pluses and minuses lying around.
No, but can't you multiply the cancel something out? It's something you could do. No.
I can't cancel anything when there's addition and subtraction.
Okay.
Because that means there's parentheses, and once there's parentheses, I can only deal with the top and the bottom individually. See, over here, this is not equal to 5/4. This is equal to 7/6. It's equal to 7 6. So that doesn't work canceling through addition. It's not going to work. So before we can begin, we have to take the top and do exactly what I did with the numbers over there. I need to factor it. How do I factor 2x squared plus 5x minus 3? The first and the last. So 2 times 3 is? 6. Factors of 6 is subtracted to 5. 6 and 1. They have to subtract, not add. So it'll be 6 and 1. What kind of 6? What kind of 1? Positive 6 and? Negative 1. Bring down the first, bring down the last. So we get that. And you group and factor. A little review of, factoring. So GCF of the first two, 2x, what's left behind? X plus 3. GCF of the second two, nothing to kick out, so I'm going to get rid of the negative and a 1 left behind. Remember, it's out by division, so negative 1x divided by negative 1 is x. Negative 3 divided by negative 1 is positive 3, so you get x plus 3. The other hint is the first one was x plus 3, so the second one better be x plus 3. Don't just guess, though. And then kick out x plus 3. So the top becomes x plus 3 times 2x minus 1. Okay. Do the exact same thing for the bottom. Little side work. The denominator is 2x squared minus 7x plus 3. I set this one up so you can see the difference of plus and minus. It starts off exactly the same. 2 times 3? 6. Factors of 6 that add up to negative 7.
1 and 6.
1 and 6. 1 plus 6 is 7. So we're going to get a 1x and a 6x. I'll switch their ordinates with the font of it. What kind of signs?
Plus.
Negative on the 1 and negative on the 6. They're adding up. They're going to be the same sign. Bring down the 2x squared. Bring down the positive 3. Real quick. What can I kick out of the first two?
X.
An x. What's left behind?
2x minus 1.
GCF of the second two?
3.
Careful.
Negative 3.
Negative 3. Left behind?
2x minus 1.
Because positive 3 divided by negative 3 is negative 1. And then we can kick out 2x minus 1. And leave behind x minus 3.
Now you can cross them out.
Yes, but before I do that, I want to teach you one extra little step. One little problem with having a variable in the denominator. If I write this, is it true for all values of x? Can I substitute any value of x that I want into that expression? No. Which one can I not? 0. I got to be really careful with variables in the denominator because they cannot be equal to 0. So my question to you is, here's my fraction. What can the denominator not be?
0.
Well, I definitely don't want x equal to 3 because 3 minus 3 would give me 0. So I have to kick it out. X cannot equal 3. Now, over here, I have 2x minus 1. When does that equal 0? When x is equal to 1/2. You'll add 1 and divide by 2, if you want to think of it that way. You're really setting it equal to 0. And to solve that equation, you would add 1 and divide by 2. So we definitely don't want x to equal 1/2, because that'll give me a 0 in the denominator. 2 times 1/2 is 1. 1 minus 1 is 0. I don't want that to happen. So I'm going to kick these two out. This is called the domain. I need to know what values of x are going to work, and I also need to know what values of x are not going to work. So I can't use those two values. Now I can cancel. I have multiplication at the top, multiplication at the bottom, and they have a common factor. 2x minus 1 divided by 2x minus 1 is 1. I highly suggest you do that at least. Show at least 1, 1. And then whatever's left over is your answer. So x plus 3 over x minus 3. Do I need to keep them in parentheses?
No.
Why? Because that long bar represents grouping symbols, so you don't need the grouping symbols, as long as there's only 2 of them. One on the top, one on the bottom. If there's more, you might have to keep the parentheses involved. Isn't this crazy?
What was the point of showing the domain?
What was the point of showing?
The domain.
Oh, because eventually that's going to be your worst
It
topic.
sure is.
Trust me, it's going to be like, I'll ask for a domain and you're going to be like, you're going to hate me asking it, but I'm going to do it a lot. This whole chapter is basically, or section is just
It's
rational,
P6, right?
P6, P6, continue, rational expressions. For example, if we have 8x squared minus 72 all over x squared plus 2x minus 15. That's a little baby example. Whenever you're dealing with fractions, you should always try to reduce them. Reducing numbers is easy because sometimes you can see what goes evenly into both of them. When you're trying to reduce this type of fraction with variables all mixed in, you don't know what they have as common factors. So the best way to do it is to factor it out. How do you factor the top?
You take out your GCF.
You take out your GCF. So I would do a little side work here. Kick out the 8. Left behind is x squared minus 9. And x squared minus 9 factors rather nicely. So 8 out front, what's x squared minus 9 factor into?
X plus 3, X minus 3.
X plus 3, x minus 3. And how do you factor x squared plus 2x minus 15?
You foil it.
Anti-foil it, but
Foil.
factors of 15,
Mhm.
then subtract up to 2.
5 and 3.
Positive 5, negative
3.
Positive 5, negative 3. I'm going to shortcut this one because it has a lead coefficient of 1. X plus 5, x minus 3. That's the shortcut method. Those two numbers you pick in the beginning actually become part of your answer. But that only works if you have a lead coefficient of 1. When it becomes something different, you have to go the long route and actually expand it and group and factor. All right, before I go any further, what can x not equal? What's the domain?
It cannot be
5, 3.
It can be 5 and it can be not 3. It can't be
negative 5.
negative 5 and it can't be
Positive
positive 3. Is that what you said? I didn't hear the negative. All right, after you do that, it's straight multiplication at the top, straight multiplication at the bottom. That's the only time you can cancel. So what's the only thing that cancels here?
X minus
When you do it, say x minus 3 divided by x minus 3 is equal to 1. That 1 comes in handy when everything cancels. That way you know what's left behind. On the top is just 8 times x plus 3. You can leave it in factored form. You don't have to distribute it back out. And in the bottom I have x plus 5. Notice I kept the parentheses around the x plus 3. Why?
Because
It's multiplied by the 8.
It's multiplied by the 8. Notice I dropped the parentheses for the x plus 5. Why?
There's nothing there.
There's nothing there, and plus that long bar represents
Grouping.
grouping. So there's parentheses there, you just don't see them. You just don't see them. All right, so that's simplifying rational expressions. What about multiplying them? Oh, it's the same as division. So I'm going to cover it all in one fell swoop. How do you multiply fractions? Well, if you have a over b times c over d, how do you multiply this?
do you cross multiply?
Cross multiply. You really want me to come after you, don't you? Straight across. So it's going to be a times c in the top over
B, D.
b times d in the bottom. My suggestion to you is you do these problems exactly like that. You see this mess times another mess, just take the two messes and put them together as one huge fraction. That way you don't get confused that you have two pieces, you just really have one piece. All right, so for example, let's see. X squared plus 4x minus 12 over x squared plus 4x plus 3 times x squared minus 4x minus 5 over x squared plus 9x plus 18.
Don't you just follow that?
Oh my gosh. Please don't multiply things together.
No, I want.
You mean factor.
That's what you mean.
You meant factor. Or are you going to multiply this times this?
No, I was going to just take, like, put parentheses around the x. Yeah, and then put a parentheses. And then just. No.
That's what I'm saying.
Okay,
You start
no.
doing loopies and you're making this problem 20 times harder than it really is. What you want to do is you want to write the factors of everything you see.
Okay.
So when you're dealing with rational expressions, your first rule is factor everything you're dealing with. So how do you factor x squared plus 4x minus 12? Factors of 12 that subtract up to 4.
2 and 6.
2 and 6. So I'm going to write this as x plus 6, x minus 2. It's the 2 and the 6. Go ahead.
No.
You want me to do it the long way?
No. No. No.
Trust me, it comes after this
Yeah.
answer.
No.
I mean, the whole thing is still the language. Factors of 12 is subtract up to 4.
I think that's what I was
I'll
trying
do
to
it one
say,
way.
but I didn't say. I wanted to foil. That's when I said foil.
Anti-foil, let's put it that way.
Yeah.
You want to
that way.
unfoil
Backwards.
this. Backwards, yes. All right, over. Notice how long I drew my fraction bar. I'm making exactly one fraction out of this mess. Factors of 3 that add up to 4.
1 and 3.
1 and 3, so you get x plus 1, x plus 3. All right, factors of 5 over here that subtract up to negative 4.
-5 and a +1.
Negative 5 and a positive 1. So you get x minus 5, x plus 1. And then factors of 18 that add up to 9.
6 and 3.
6 and 3. So we're going to get x and a 6, x and a 3. What kind of 6, what kind of 3?
Positive.
Both of them positive. So we have this one huge fraction with a bunch of little factors in it. And by the way, just for the fun of it, x cannot equal -1, x cannot equal -3, x cannot equal -6. I don't need the last one because it's the same as the second one. So -1, -3, -6. Now since it's all multiplication top and bottom, exactly the way I want it, look for common factors. Well, there's an x plus 6 in the top and there's an x plus 6 in the bottom. They have to be identical. Not just same pieces, they have to be, everything's identical. Replace it with a 1. X minus 2? No. X minus 5?
No.
No. X plus 1?
Yes.
Woohoo! They're gone. That becomes a 1. They inverse identity out. And then whatever's left over has to be your answer. So in the top is going to be an x minus 2 and an x minus 5 times 1 over,
X plus 3 squared.
I'd rather you write it x plus 3 squared. There's 2 factors of x plus 3. This is easy.
And you're just gonna leave the numerator.
Numerator and denominator, leave it in factored form. When you're dealing with these things, don't ever multiply them back together.
Okay.
After you factor them, you're happy. There's only one place where I want you to multiply it, and it's usually in the numerator. Never ever the denominator. Ah, come on. New markers.
I have an elementary question.
Elementary. Go for it.
What is elementary? I told you it was elementary.
Numerator, top. Denominator, bottom.
So it's like blood
When you say
pressure.
common denominator, bottom.
Down.
Okay, it's backwards. It's like blood pressure. How about systolic over diastolic?
Stop it. You're just going to confuse me. All right, division problem. If you're dealing with division, AB over CD, or this is the same thing as AB divided by C over D. You need to know this for the entire course. Whenever you divide by a fraction, what?
I'm gonna ask that question. When you have that, could you do like AB and then times DC?
Yeah, that's what I'm getting to.
Oh, okay.
So this is going to equal A over B times the reciprocal of the bottom, or the reciprocal of the division fraction. And then when you get it into that form, it's just AD over BC. You just multiply it. So division and multiplication are technically the exact same operation. Just like addition and subtraction is technically the same operation. All right, so let's see here. Division problem. X minus 2 over x squared plus 6x minus 7 divided by x plus 7 over x squared minus 8x plus 7. Now, I'll give you a couple hints. If this is written in the textbook this way, don't copy it on your paper this way. You might as well flip that second fraction and be done with it. The way I'm going to do it is I'm going to flip it as I factor it. So I don't have to copy it down and then worry about it. The first fraction is not going to change. I am going to put it in parentheses. The bottom one, denominator, the bottom. Denominator, the bottom. Factors of 7 is subtracted to 6.
1 and 7.
1 and 7, what kind of 7?
Positive.
A positive 7 for sure. So we're going to get x minus 1, x plus 7. We know they're going to be opposite signs because it's negative 7. Then here, the bottom is going to go to the top. This is going to move up, and this piece is going to move down. So I'm going to put the x plus 7 in the bottom. And then factor the bottom one up here. So factors of 7 that add up to negative 8.
1 and 7.
Negative 7 and
X minus 7 and
X minus 1.
x minus 1. Okay. So now everything's on the right side. X minus 2, does it cancel?
No.
No. X minus 7?
No.
No? Darn. X plus 7?
No.
Wait a minute, I'm missing one. X minus 1, I'm sorry.
I was gonna say X minus 1
X
cancels.
minus 1 cancels. That's it, isn't it?
Yeah.
That's horrible.
so do we FOIL the?
Please
FOIL
don't.
the remainder?
Leave it alone. Leave it alone. This is x minus 2, x minus 7, over x plus 7 squared. Just leave it alone. That it actually is neater this way. Plus, I also know a few things about it. What makes this thing equal to 0 is 2 and 7. What number you cannot use is negative 7. You multiply it all out, and you lose a lot of those possibilities. It's better to analyze it in factored form. All right, so that's division. It's the same as multiplication. So what do we spend a lot of our time on?
And let's get my beard in there.
Addition and subtraction. And the problem with spending a lot of time on addition and subtraction is you start using the ideas in addition and subtraction with multiplication and division. You'll see a multiplying problem, and all of a sudden you're getting a common denominator, which will throw everything out of the, make it all crazy.
I do that.
So, how do we add and subtract? Just remember that multiplication and division is actually easier than addition and subtraction. There's a lot less errors with multiplication and division. Adding and subtracting comes up with errors because there's a lot of sign mistakes. Lots of them. So let's start off with a over b plus c over d. How do I add fractions together?
We have to find the
Common denominator. Okay. So when you're finding a common denominator, you're trying to force the bottoms to be exactly the same. So the way I say it is, this one has a b in the bottom, this one has a d in the bottom. What is the left one missing that the right one has?
The D.
The d. So if I put a d in the denominator, I better put one in the,
numerator.
why?
Because
Because
they
you
will be
want-
the same.
You
Why
have
do they
to
have to be
use
the
it
same?
at the bottom, you have to compute it.
No.
In order to add, they have to be the same.
No. Why do the d's, those green d's, have to be the same?
Maybe do the bottom, maybe the top, or where you do
Why?
Oh,
You said so.
No, I never say anything.
Is it
Everything always comes back to a property.
is it
It's a what?
inverse.
Inverse identity. Because d over d is equal to,
1.
and 1 times anything is itself. So by making the top and the bottom exactly the same, I'm not changing the value of a over b. Over here, what's missing in the bottom?
B.
b. I could put it in the bottom, I better put it in the top. It's that identity inverse thing. Okay. Or in this case, it's inverse identity order. All right, here's the cool part. Once you have a common denominator, in this case BD, or DB, I don't care what order you write it in, they're exactly the same. So we're going to use the distributive property and pull it out. To pull it out, we're going to write it as 1BD. A lot of people get confused and say, well, what happened to the other one? Well, it's being factored out, literally. What's left in the top is AD plus
CB.
BC. I like alphabetical order. But if you put it opposite, it's not going to kill you. And that's how you add fractions. And that's why you need that common denominator. You want me to expand on that factoring part? If you have 4 sevenths plus 3 sevenths, right? The reason that they add together because of the bottom is you can write this first one as 1/7 times 4 plus 1/7 times 3. What do they have in common? The 1/7. So you kick the 1/7 out. What's left behind is 4
Plus 3.
plus 3. And then you get 1/7 times,
7.
which is better known as?
1.
That's what it means to be a common denominator. Anything in common, you can pull it out. Want to see another one?
Yeah.
Okay. 5/8 plus 1/8.
I think what's I'm not catching on is if B and D
Are not necessarily
Not
the
the
same.
same.
Not necessarily the same.
not necessarily the same.
I know, but
But if they
well,
are the
we
same,
assume that they're
but if
different.
they are the same,
You can just pop it out. Oh, well, hold on. How about this? I won't do 1/8 plus 5/8. Let's do 5/8 plus 5/6. There, they're different. Ah. All right. Now 8 is 2 times 2 times 2. 6 is 2 times 3. What's the left one missing that the right one has?
It's 2.
A 2. What?
There's
A 3.
3.
My bad.
3. So I'm going to multiply the bottom by 3, but if I multiply the bottom by 3, I better multiply the
Top.
top by 3. What is the right missing that the left has?
A 2.
A 2.
An extra 2.
Just 1 2?
2 2s.
2
That's
2s.
four.
I have 3 2s on the left, I better have
3
3 2s on the right. So I'm going to multiply top and bottom by 4.
Well,
I know.
it's
What the mentality I'm going for is the algebraic mentality.
okay.
I know, you could probably do it with your
I-
calculator.
I used it with my brain this time.
Oh, okay. But the same answer is going to come out. It's just that this is how we're going to do it with algebra. We're going to factor the bottoms, we're going to see what's missing, and we're going to include it top and bottom. It's the same pattern from algebra. All right, what's left in the top? Over here.
15.
So this will be 15 over 3 times 8 is 24,
24.
plus
20.
5 times 20
Over 24.
over 24.
And that's
And I can pull that 24. This is the what happens when you really add like fraction or like denominators. You're factoring out a 24. What's left behind?
The 15.
The 15 plus
20.
20, which is also known as 15 plus 20 all over 24. These two statements, bottom two, are identical. They are identical. Why? Well, this one has parentheses grouping the 15 and 20. This one has a long bar grouping the 15 and 20. The 24 is in the 24 is in the, they're identical. So now you just go, well, 15 plus 20 is 35 over,
20.
do they have any common factors?
No.
75, 3 and 8 now. So that would be your answer. I mean, that's the long way to do it, but this is the way we're going to do it today.
Because we get nastier.
Oh, yeah.
Not gonna make it nastier.
That's just, a foregone conclusion.
But you know what I find easier if you do it not side by side but up and down. For me, I find that.
I am doing it up and down.
No, that's not what I meant. Like, you see how you had.
I know what you're saying. You're
Okay.
saying, write it this way.
That's what helps. Yeah, it helps me out.
God, no, not with algebra.
That would confuse me.
You know, with algebra, that would be horrid. With numbers, yeah, that's 4th grade math. Don't do it that way anymore. Please don't do it that way anymore. And don't use your calculator to do fractions either. Get used to doing it by hand, because if you can do it with
Oh, I didn't
numbers,
use my calculator.
if you can do it with numbers by hand, you can do it with algebra. They're exactly the same. The pattern is not going to change from over here. For instance,
She had so much confidence.
let's make up one. Simple one. 5 over 2x plus 3 over 3x squared. That's as simple as I can make it. Well, actually, I can make it simpler, but that'd be boring. Now, when you're looking at these, the golden rule for adding fractions is literally factor the denominator. The numerator isn't as important as the denominator when you're adding fractions. With multiplication and division, you factor everybody you see and go from there. So, can I factor the denominators? Not really. There's nothing much there. So, I'm going to start in with my language. What's missing on the left in the bottom that the right has?
An X and a 3.
An extra x and a 3. So I'm going to multiply over here by
3.
3x, top and bottom. All right, if I go over onto the other side, what's missing on the right-hand side that the left now has?
2.
Just the 2. So I'm going to put it in top and bottom. Yay. Now, when I write the denominator, I'm only going to write one of them. What is the denominator?
6x squared.
It's 6x squared in both locations, so I'm just going to write it once, because technically I'm factoring it out. What's left in the top? Well, 3x times 5 is 15x plus 6. There's your answer.
Okay, it does.
Yeah, that's what I'm saying. If you do it this style, I mean, for numbers, that's not the best way to do it, unless the numbers get really big. But if the numbers are small, that's definitely not the best way to do it. But for algebra,
You're right.
it works really nice. How about this one? I put this on a test one day, thinking, oh, this will be a nice, easy question for them to do, and it shows me that they know what they're doing. So I wrote down 4 over 3x plus 6 minus 2 over 4x plus 8. And I'm thinking, oh, they'll be wonderful with this. Boy, was I wrong. What did most people do? They went and looked at it and went, oh, the left-hand side is missing 4x plus 8, so they put it top and bottom. And then they went over here and they said, oh, this side is missing 3x plus 6. And they put it in top and bottom and multiplied a bunch of stuff out and combined like terms and got an ugly fraction. And then they tried to simplify the fraction, and that's when they usually made their mistake. So here's what you need to look at. Can you factor the denominators?
Yeah,
Yes. Do that first before you do anything else. What pulls out of the first one?
the 3.
The 3. What's left behind?
X plus the 2.
What pulls out of this one?
4.
What's left behind?
X plus 2,
What is missing on the left?
the 4,
A 4. Not 4 times x plus 2, just the
4,
4. So instead of multiplying by 4x plus 8, all you really have to multiply by is
4,
top and bottom. On the right-hand side, what's missing?
3,
A 3. So you put it in top and bottom to keep that identity going. Comes out a lot easier this way, doesn't it? The other way would require like 10 minutes of work. All right, one denominator, what is it?
6,
It is
It is not 16.
12x plus 24.
12 times x plus 2. Don't multiply it all out. Leave it in factored form. Now on the top we got 16 minus 6,
which is 10,
which is 10. Now, is this our answer?
no,
No.
Heck no. 10 and 12 have a common factor, which is
2,
2. You've got to get rid of it. So this is going to break down into 5 over 6 times x plus 2. And that's a perfectly fine answer. But I put this on a test to be nice, and people made it torture. They actually tortured themselves with it. Now, why would they do that? Well, because most of the problems I'm going to cover are kind of messy. For instance, what if I ask this? 2x over 3x minus 1 minus 5 over x plus 2. Now, why is this one messier? Well, the bottoms you can't factor them. They're primed. Therefore, everything that's in the bottom is missing on the other side. So when I go over here and I say, well, what's missing on the left that the right has?
X plus 2.
The entire expression, x plus 2. Never break up a denominator. I've seen people pull off the 2 and say, oh, the 2's missing. But you can't say that because it's got a plus. So you need to multiply that top and bottom. What's missing in what I've written so far on the left?
Parentheses.
I need parentheses around this 3x minus 1.
Because you're going to foil that.
Because I'm going to foil that. Well, actually, I'm not going to foil the bottom out. But I need them to multiply
Yeah.
completely. All right, what's missing on the right-hand side?
3x minus 1.
3x minus 1. I'm going to put it in top and
5.
bottom. Okay. Now I have a common denominator, which is,
3x minus 1 and x plus 2.
I don't care what order you write them in. As long as you have both of the factors down there. Commutative property is a beautiful thing. What's left up top, I highly suggest you do this step first. And there's a reason that I don't want you to foil this out or distribute it out first. Most people, when they do this, they'll get the first one right. They'll get the negative 15x, and then they'll write something like plus 5. But it really should be, well, I'm sorry, minus 5, but it really should be plus 5. If you do it this way, the negative 5 is what you're carrying through and not just the 5. So be careful. All right, the top over here becomes 2x squared
Plus 4.
plus 4x minus 15x plus 5, because that's negative 5 times negative 1. That's where the mistake will happen with you. So if you make a mistake, that's more than likely where it's going to be. That one sign at the very end. All right, and then combine like terms. Oops, this is all over. Oh, the other mistake is this. Some people get so focused on the top they forget about the, and they leave it off. This is a fraction. It has a numerator and a denominator. Keep it that way. Okay. Simplify the top, you get 2x squared minus 11x plus 5 over x plus 2, 3x minus 1. Now sometimes the top will factor and cancel with the bottom, but that is very, very rare. But it does sometimes happen. Isn't that easy?
For some reason, I like
Yeah. Just don't do multiplication this way. Just please don't do that. How much time do we got?
30 minutes.
Plenty of time. More torture. Messier. You will find, even on my tests, I don't usually do addition. I do subtraction, because I'm trying to catch you on a sign mistake.
What are you trying to catch?
That's so mean.
I need you to do what?
That's so mean.
Yeah,
That's so
why are you
mean.
trying to catch it?
I never said I was nice.
It's not like we're gonna
I've been
catch
trying to
it.
get the rumor out that I'm the worst teacher on the planet.
It's
I
out,
didn't hear
trust
that.
me. I heard it.
And
I
yet
was
you're
told
still
to try to
here.
I was told to try to go to Tarboro. Don't
Yeah.
take it with him. Go to Tarboro.
He didn't
It's
say
worth
he
the
just
gas.
kill him.
I didn't hear that.
But you're not bad at all.
I heard the other, what's her name?
Remember, we're being recorded.
Oh.
Can't say anything nasty. All right, here's a nice little subtraction problem. Ooh, before you begin one of these types of problems, you see this ugly mess on your paper. Look at what operation you're dealing with. If it's multiplication, you do one thing. If it's addition and subtraction, you do another thing. If you didn't have division, make sure you flip that second fraction. So the operation is actually more important than all the junk that's around it. Know what you're doing with first, and then go and do what you have to do to the two expressions. All right,
Okay.
what do I need to do to the left?
You need to break it down.
Break it down.
Break it down. Factors of 3 that subtract up to 2.
-3 and a positive 1.
-3 and a positive 1. Okay. Factors of 6 that add up to -5.
-6 and a 1. Which
Is it 6 and 1 or 2 and 3?
negative?
-3 and
Oh.
-2. Why? Because they're adding, that means they have to have the same sign. If you do the opposite sign, then this has to be minus.
So it's gonna be.
X minus 2, x minus 3. I'll give you another hint. If it was 1 and 6, do you see a 1 and 6 over here? And it would have to be well, there is a 1. I'll give you another extra hint. I will only ask for one factor top and bottom. I'll never ask for 2. If you find that you're multiplying top and bottom by 2 different factors, binomials, something is wrong with your factoring, because I would never ask that, because that's horribly long. All right, what's missing on the left-hand side?
X minus
X
2.
minus 2.
The x minus 2. Top and bottom. What's missing now?
The X.
No. On the left-hand side.
Oh, parentheses.
I need parentheses around that x minus 1. Otherwise, I'm just multiplying by x. I need to multiply the entire thing, x minus 1. Long fraction bar, parentheses. All right, what's missing on the right-hand side?
X plus 1.
Put it in the bottom. I don't need parentheses in the top because it's a single factor of 5. Start with right at 5. All right, now we have our common denominator.
You do.
Don't do anything yet. Get the common denominator going. So the common denominator is x minus 2, x minus 3, x plus 1. It is in the bottom of both of those fractions up there. Write down exactly what's in the top. Don't you dare do FOIL or any fancy things like that. This
That's
is x
not
minus
that's
2 times x minus 1 minus 5 times x plus 1. Just write it down. What happens is, in the above problem, the minus sign is kind of sunken low and you kind of will miss it sometimes. Here, it's directly between the two terms you need to subtract. So this way, you don't make that silly sign mistake. FOIL the first two out, you get x squared.
We can't cancel?
Cancel what?
Nothing, because we're not multiplying, we're subtracting.
Yes, please. If there's pluses and minuses, don't even say the word cancel. It's going to be x squared minus 3x plus 2 minus 5x
Minus 5.
minus that 5 because it's negative 5 times a positive 1. All over x minus 2, x minus 3, x plus 1. And then simplify the top. So this is x squared minus 8x plus minus 3 all over x minus 2, x minus 3, x plus 1. I know it gets trivial copying that denominator down over and over again. But if you don't,
You'll lose it.
you're going to lose it. You're going to write the denominator down, and I take off 3 points.
I know I do.
So keep it with it all the way through the problem. 3 points out of 5 is worth a lot. All right, time for silly mistake time. Another easy problem. You know, everybody concentrates on this type of problem, and they eventually get very good at this one. And then I'll ask something, well, silly. For example, 3 over x plus 2 over x minus, or x plus 4. I like the silly little problems because it really asks you to really understand what's going on. Since you practice these so much, it almost becomes second nature, but you don't think about it too much. This one, you have to think about it a little bit. Tiny bit. And there's a major error that I've seen. Ready? What's missing on the left?
X plus 4.
Anybody else? I have seen people say 4. And they'll put 4 top and bottom over here. Why? Because they see this x and they're like, oh, this one already has an x.
But it's added.
And then you just put the 4 over here. You have to remember that this fraction bar means parentheses. That is the factor x plus 4. It is different than the number called x. Think of it this way. If x is equal to 5, this side would be equal to?
X.
If x is equal to 5, then this side would be 9. And then this side would be missing 9. You don't just put 4 top and bottom, you have to put the 9. So what's missing over here is literally x plus 4. I'm not going to finish this problem, I just wanted to point that out. You see these long fraction bars, you might want to start just putting parentheses everywhere you see them. What's this side missing?
X.
Just the x. Alright, that's enough of that one. A very important topic. Put a little star here because I love this one. This is a complex fraction. And the only reason these become really important is they show up all the time when you're dealing with math, upper level. And you have to be able to simplify things quickly. And it becomes a nice, neat way of doing it. So what is a complex fraction? Well, a complex fraction could be 2/3 over 4/5. Anytime you have a fraction within a fraction within a fraction. So you have these two fractions inside of a bigger fraction, that becomes a complex fraction. We know how to simplify this one. How do you simplify this one?
3 times 5.
You multiply 2/3 times
5
5/4. You flip it, multiply. This is a complex fraction. Why? Well, because it's a big fraction with little fractions inside of it. So I need a quick way of breaking these down to be a regular fraction, a numerator and a denominator, a top and a bottom. So, simple example with numbers. I want to show you elementary school way and my way. I guess if you ever get stuck, you can always go back to the elementary school way, which is fine, but it takes a lot longer. So something like 2/3 minus 5/6 divided by 3/2 plus 7/4. That is definitely a complex fraction. Fractions inside of fractions all over the place.
Okay.
Go ahead, what are you going to say? If it's my shortcut, I don't want to go that way yet.
No, it's not a shortcut. I was just gonna say, would my way be elementary school if I tell you? If I probably would be. Could you just break them down, subtract and add everything and then flip after you? No, that's too.
Yeah, that's basically elementary school way. You get a common denominator for the top, you get a common denominator for the bottom, put everything together, flip and multiply.
Yeah.
So what's the common denominator for the top?
6.
6, so we're going to multiply over here by 2, right? And what's the common denominator for the bottom?
4.
Another one, so we're going to multiply by 2. So this becomes 4, 6 minus 5/6 over 6/4 plus 7/4, right?
Yeah.
Okay, then you add them together, so this becomes negative 1/6 over
13.
13/4, and then you have to flip and multiply, so it's negative 1/6
Times
4/13. So this becomes negative 4 over 78. Cross can. Oh, yeah, you can. I'm not going to do it though. 78, right?
Mm-hmm.
And then they have a common factor of 2, so that'd be negative 2 over 39. Yes, you can cross cancel. What allows you to cross cancel?
4.
Well, no, in the sense of this is actually negative 4 over 6 times 13. And they cross cancel because 4 has a common factor and 6 has a common factor of
2.
2. The only reason I hate cross canceling is other people will say cross multiplication. Remember you said that the other day? But that's where they get confused. Cross canceling and cross multiplication are 2 different things. One's an equation, one's an expression. But if you want to do it, go right ahead. Just be careful with that. Now, I find that extremely tedious. That takes way too much paper, way too much time. So here's my way of doing it. 2/3 minus 5/6 over 3/2 minus 7/4. Oh, I'm sorry, plus 7/4. My way goes a little bit different. This way, you worked with the top and the bottom individually. You created actually 2 separate problems out of it. My way does this. I'm going to create this, or treat this as one fraction. And I know with a single fraction, I can multiply the top and the bottom of it by anything that I choose because of the identity property. So what I'm going to choose to multiply the top and the bottom by is 12.
Because they all have that common.
It's a common denominator. If I was going to add all of these fractions together, the common denominator would be 12. Or you can think of it as every one of these numbers divides evenly into 12. So you can use any number. 24 would work also.
So you want to multiply both top by the same number.
Exactly the same number. You can't change it. Because 12 divided by 12 is 1. I need that to be 1. Now, why did I choose 12? Is because 3 goes into it, 6 goes into it, 2 goes into it, and so does 4. It's a common denominator if I was going to add every of these fractions together. All right, distribute it out. What's 12 times 2/3?
4.
8.
Let's see, 3 goes into 12.
4.
4 times 2 is
8.
8. Okay. I always divide up because I know it's going to go into it. So divide up, multiply across. 6 goes into 12. 2. 2 times the 5?
Negative 10.
Negative 10. Over. 2 goes into 12.
6.
6 times the 3 on the top.
18.
18. Plus 4 goes into 12.
3.
3 times 7?
21.
Negative 2 over 39.
Oh.
You cut out about half of the work. You cut out about half of the work.
Wow.
Now, would it work over here with this simple little fraction? Well, yeah, what's the common denominator between 3 and 5? 15. So you multiply top and bottom by 15. 3 goes into 15?
5.
5 times 2?
10.
5 goes into 15?
3.
3 times 4?
12.
And this is 5, 6. It's just a quick way of doing it. What would I have to multiply the second one by? 2, top and bottom. So if I multiply by 2 on the top, and 2 in the bottom. 2 times 1.
Two.
Nothing's canceling there. It's not a fraction, so you get 2.
But
Plus.
one.
2 times 1/2
One.
It's one,
over 2 times 2.
four,
So this is
3/4.
3/4. It's a neat technique. It works really quickly. Of course, it's much better when we deal with, variables
I don't think so.
and terms and all that fun stuff.
That's when it turns into a math.
Well, yeah, basically. Basically. Let's see. For
You wanna show
example,
us how to do it with the variables in it?
3 minus 2 over x squared over 1 over x plus 1.
See, this is what I'm talking about.
What is this thing? Well, it's a complex fraction. What's the common denominator? X? X squared. See, this one has an x in it, but this one has a x squared. So this one would be missing
And
an x. So the common denominator is x squared. X squared. They all have to divide evenly into it.
Okay, so it's because you couldn't do the x because it wouldn't do
This
it
one
to the-
wouldn't divide into it
okay,
evenly.
gotcha.
It would only go in and leave something in the bottom. You can't have anything in the bottom. So I'm going to multiply top and bottom by
X squared.
x squared and distribute it through the top and distribute it through the bottom and see what happens. Okay. So x squared times that 3.
3x
3x squared. When I do x squared times 2 over x squared, what happens to the x squares? And you're left with
Negative two.
a negative 2 over 1 over x times x squared.
That leaves an x.
That leaves a single factor of x plus 1 times x squared.
X squared.
You're done. Not much else you could do there. I guess you could factor an x out of the bottom, but it doesn't help. Doesn't help. All right, let's make it worse. 2 over x squared minus 1 plus 3 over 1 over x minus 1 minus 1 over x plus 1. I'm just making them up as I go.
Oh,
But it's
it's
still
x
deep.
minus 1, x plus
What do you need to do first?
1. You foil it down. Well, not foil.
Please don't say foil.
Defoil.
Defoil factor.
Factor.
X squared minus 1 factors into
X plus 1.
x plus 1 and
X minus 1.
x minus 1. You just keep that in your head if you want to. What is the common denominator of this mess?
X minus 1, x plus 1.
X minus 1, x plus 1. So I'm going to take the entire top and the entire bottom, multiply by x plus 1, x minus 1. Or x minus 1, x plus 1. I can care less what order they come in. But these are multiplying, they are not dividing. And then you distribute it through. Okay. If you distribute it to the first term, 2 over x squared minus 1, what happens?
They
Because
cancel
bottom
out.
cancels with what you're multiplying in and you're left with
Two.
a 2. Plus, what happens when 3 runs into that mess?
You have to distribute.
Well, you get 3 times x plus 1, x minus 1. All over. Can't do much with that. What happens when it runs into this first term way over here?
Can't.
X minus 1s go poof,
So it's x plus 1.
so you get x plus 1. Minus, when it runs into the second one,
They can't. X plus 1 is canceled.
and you're left with
X minus
a 1, don't forget the 1 on the top, times x minus 1. Notice I left the bottom in parentheses. Why? That negative, that minus sign is going to mess people up. So the top, x plus 1 times x minus 1 is x squared minus 1, right?
1.
So this will be 3 times x squared minus 1, which is 3x squared minus
3.
3 plus 2. So that'd be 3x squared minus 1. Over. Ooh. X minus x.
Yes. Negative x.
No, what's x minus x? 0. What's 1 minus a negative 1? 2. God, I hope it doesn't turn out to be 0. That'd be horrible. And there's your answer. 3x squared minus 1 over 2. Woohoo!
What did you do with the two? I
Which
missed
one?
something.
This one?
I had my
Oh.
yeah.
This is x squared minus 1.
Yeah.
that becomes 3x squared minus 3. Minus 3 plus 2 is, oh, I'll write it out.
Yeah,
This is 2 plus 3 times x squared minus 1, which is 2 plus 3x squared minus 3.
okay. Oh, okay, -1. Got you now.
That becomes the
Thank
negative
you.
1.
Just need it broke down a little bit.
So where do these show up?
That's weird.
They show up in problems that look like this.
Okay.
For example, 4 over x plus h minus 4 over x all over h. They show up in problems that look like this.
So you're missing a.
Well, is it a complex fraction?
Yes.
Yeah. So what would you multiply top and bottom by?
Say H.
H is X plus H.
Why are people
I
doing
mean,
this
X
weird?
plus H.
You see this long fraction bar? This automatically gets parentheses. What is missing?
The H.
No. What is the common denominator?
X plus
X plus h and x. You can't separate the x and the h. Oh, and this h, by the way, has a denominator of 1. So when you say the common denominator, you're looking at a 1, an x plus h, and x. So you need to multiply top and bottom by x plus h. You cannot separate binomials. They have to stay together. So when I distribute out that top, x plus h is going to run into 4 over x plus h. So it'll be 4x. Minus x times x plus h is going to run into 4 over x.
So it's
-4.
4 times
X plus H.
the quantity x plus h. All over, can I do anything in the bottom? Anything canceled? Nope. X plus h. Hey, this is easy.
That's a test
Possibly. Now, here you have 4x, here you have minus 4x.
They cancel.
They cancel. Negative times a positive h is a negative h over hx, x plus h. No. Never ever multiply things back together. Leave them factored. What happens here?
You can cancel.
I can cancel an h. H divided by h is 1. I need that 1 up there now. So the final answer is -1 over x times x plus h.
Wait,
Oh, I lost something. I
the
lost something.
H.
Nope.
No.
I lost something.
The -4 and the
4.
H. That's what's confusing.
-4 times a positive h is?
-4H.
So this should be
-4.
over x times x plus h.
Yeah, that's what I was.
I didn't
I was
just
wondering,
separate
you had to
that.
distribute.
Uh-huh. I was waiting for someone to catch my mistake.
When I wrote it down, I was like,
That's called calculus.